That's it.
You're not going to hear yourself inside, but it's going to be going to go into this.
Okay. But Jason will need first, right? He will need first, and then I will click it.
Oh, you want the handle? Yeah. Microphone of a live, you know, workshop.
What's the point?
In person attendance. I'd like to explain more about some. So, non-governmental organization. We function as a membership organization, which essentially has members across from developers. So we were doing the energy. Our vision is for the be a globally sustainable, and we do this by acting as a hub and um, especially as they come, folks, and we will be. So, without further ado, I would like to just finally ask everyone on the webinar to just fill in that survey as you complete it. Today, the system on its controls and demand HVAC controls. So thank you so much.
I've been with Siemens for almost 17 years now, and that's my contact details. If you have any questions or anything, if you want to get in touch with me, please feel free to contact me anytime on my email address. Yeah. So what exactly is intelligent lighting control system here? So in this presentation, I will start first with the conventional concept and the way how we are doing intelligent lighting control. We all know that if we change the conventional lamps to LED lamps, we get a saving of around 70 to 80% because LEDs are of low wattage, yeah, and you get automatically a saving of 70 to 80%. Yeah. But if you have an intelligent lighting control system over this, then you can have an additional saving of 30 to 50% by implementing a right intelligent lighting control system. So when I say intelligent lighting control system, in this presentation, I will be focusing on three important aspects of lighting control. One is daylight harvesting. Yeah. human-centric lighting control, and constant brightness control. So these are the three important topics of intelligent lighting control which I'll be covering in today's presentation. Yeah. So where do we implement this intelligent lighting control system? Yes, as we know, we are all doing this. Common area lighting controls like corridors, car park areas, toilets, gym, prayer rooms, yeah, external lightings, lobbies, and also staircases. So let me take some few examples. We've got a wide range of sensors. Yeah. So I will be also going in detail about the different types of sensors and how we do this intelligent lighting control with sensors. So what you see on the first extreme right hand side is the corridors. Yes, we have got a wide range of sensors. It could be a motion sensor, it could be a presence detector, it could be a ceiling mount sensor, wall mount sensors, absence detector, a wide range of sensors through which we actually control those lights based on occupancy. Yeah. Similarly, the car park areas, generally we work with consultants, we work with our partners, and we make sure that you have a perfect lighting control for the car park areas. So when we get a project of car park areas, we divide the project into various zones, and then each zones there is an entry point and exit point, and we divide that zone into two parts. One is the driveway part, and one is the parking area. So there is a minimum illumination which is required is maintained by the alternate circuits. So for example, in the driveway, if you have got 2 or 3 circuits, we will keep one of these circuits on 24 hours. So for example, 6 a.m. to 6 p.m., one of the circuit will be turned on, and then from 6 p.m. to 6 a.m., the next circuit will be turned on, so that we maintain our minimum illumination in the driveway. And as soon as a car enters into a particular zone, there are sensors. Again, these are IP55 sensors, IP54 sensors, ceiling mounted, wall mounted sensors in our product range. That whenever the car enters in, it turns on that particular zone. Yeah, and as soon as the car leaves that particular zone, and then it goes back to the normal scenario where we maintain again a minimum illumination in the driveway. Similarly, we also have sensors which are not visible. For example, in the washroom areas and toilets, you may not be comfortable in putting a sensor on the wall or on the ceiling. We can have a sensor which is an ultrasonic or a microwave sensor which goes above the false ceiling and it is not visible. Same way, if you have got a nice lobby with lot of nice architectural effect, and if you put a sensor, it may look ugly, or sometimes the design, it gets interrupted with the sensor. So in such applications, we also have sensors that goes above the ceiling and it's not visible at all. Yeah. Similarly, controlling the external facade light and also the common areas like the staircase lighting. The normal business what we do, and it's a part of the spec in this region, and we've got a wide range of sensors that does this. But if you go to the professional lighting control, yeah, they're also there. Yeah, when you talk about professional lighting control, it can be a stadium, an indoor stadium, or an big stadium. What you see here, architectural lighting, smart offices. Yeah, and I will be going in detail about what exactly we do in lighting control in those areas. Yeah. So let me start with the architectural lighting. So if you see now, the UAE National Day is coming, and you want your project to be illuminated with the color of UAE flag, or if you have a VIP guest, and if you want that particular building to be illuminated in whatever colors you want, we can do this. How we do this? So with our RGB controllers, which is on DALI, you can mix the lights in any fashion what you want. So what you see here is an RGB light. You can mix it, and in today's world, we have got different types of LEDs. So what you see here is an LED which is a concentrated LED, and then you have got also a distributed LED, which is generally used for wall washers. Yeah. For example, if you want me to illuminate the walls with the Siemens logo, which is something like this, which is green, hashtag 099. So what exactly is 099? It means if I keep R at 0%, if I keep green, which is the green light at 60% and blue at 60%, the controller will turn on those lights in such a fashion that the building will look, or the wall will look completely green like the Siemens logo. Yeah. So that's very common now in architectural lighting. We do this. Yeah, and any of your projects, please feel free to contact us whenever you want to do any architectural lighting control. Similarly, external lights. How do we control external lights? Yeah, we put a photo sensor a normal LDR. LDR turns on the light where we define a threshold brightness. But in Siemens, we do this in an intelligent way. So when I say intelligent way, it means the sensor what you see here. In all our projects, we put this one of these sensors. Yeah. So wherever you have your project location, it can be in Abu Dhabi, Hatta, Dubai, wherever you put the sensor, you just put the longitude and latitude of the project site. Yeah. And then the sensor is smart enough here. It has got 100 years of program. If you ask the sensor the sunrise time on 2050, 1st of Jan, the sensor knows this. And it actually compares this with the actual conditions. When the sun rises in the east and it goes to the west, so it's monitoring that also. And it has got an astro function. Yeah, it compares the actual condition. And with this sensor, you can define 5 thresholds. So for example, threshold number 1, I can say 50 lux. Threshold 2, 30 lux, or threshold 3, say 10 lux. So when it is actually 50 lux, it turns on the walkway, what you see here, the sky is still blue, but the walkway or the driveway, we first turn it on with 50 lux. And as the illumination decreases, when it is pitch dark, you can turn on all your facade lights, the boundary lights at 20 lux. So you can program it in such a way, and anytime you can do these changes, yeah, from the BMS or from the lighting control PC. Yeah. Now I'll be going in detail about the constant brightness control, what exactly is constant brightness control and how constant brightness control is changing. Okay, again, this field is getting more and more advanced in coming days. So let me give you an example. This gentleman which you see here is comfortable with 500 lux. Yeah, so he is comfortable with 500 lux, and in order to be comfortable with 500 lux, so what we do is we put a sensor above him, what you see. Yeah. This is also, for example, in our offices when we come in. So the desk is dedicated for him or for me, for example. Yeah, but things are changing after COVID. The desks also, we book it now through our apps and we book it. So let me take you first before COVID, what was the situation, and then after COVID, I will go into this. Yeah. So before COVID, if this gentleman was sitting over here and he's comfortable with 500 lux, so what happens is first when he sits in his desk, the sensor understands that this desk is belonging to person X or person, or for me, for example. It will first check the position of the sun. So this sensor, which is there in your project on the roof, it understands the position of the sun. So for example, if I'm sitting and if I want 500 lux, it will not just open up the complete blinds. So if it opens up the complete blinds, then I may get a glare, the space area may get heated up. So what it does is, it will not turn completely the blinds up, but it will adjust the lamella. So whenever you have a blinds, you have got the string through which you go up and down, and there is a stud through which you rotate and adjust your lamella. So here, the lamella will be adjusted in such a way that you get the reflected light. I will be using this term lamella quite often because in coming slides the word lamella will come in. So the lamella will get the reflected light in, and as soon as the sun changes its position, the sun is in front of me, once it's in it. So what happens? The blind completely opens up. Yeah. Then the sensor measures it, and based on the defined target left, it will turn on the lights. Yeah, so these are the lights which are on Dali, which you see. So the first lamp, which is next to the window, is turned on with 28% brightness. And as soon as you go towards the corner, the illumination increases. So it's not just turning on the light or playing with the dimmer. So the sensor here is very intelligent and smart enough, and it tries to maintain a constant brightness which we need, which is 500 lux in this case. Yeah. So this will be maintained by the sensor. So the sensor here is right now, it's also a brightness sensor. It's also a presence detector. Okay. And now we are moving into a advanced sensor, which we call it as one room, one sensor technology. And it takes care of the 4 important aspects. Apart from energy saving, which we discussed, apart from comfort, it also takes care of the health, and it also takes care of the asset management. So these are the 2 important features. And when we talk about one room, one sensor technology. So what exactly is this comfort and human-centric lighting control? So I'm going into this topic of human-centric lighting control. What you see on this slide is every one of us have a clock within us. So there is a clock within our body. So it's very important that this clock needs to synchronize with the nature's clock. Yeah. So if you see, this is always a question. I always talk to my customers. I also tell my wife, if my son is going for an examination, please put him inside the yellow light. Yeah, the yellow light, he's active. Yeah, so it's a big question whether you like yellow light or white light. It's generally, in this slide, I'll be talking about the color temperature of the light, how we pray. So this color temperature can be adjusted in the controller from 2700 Kelvin to 7000 Kelvin. You can adjust this, and this technology brings you close to the nature. And for your well-being, this is one of the important aspects as well, the human-centric lighting control. Now, if you see this, yeah, at 6 a.m. in the morning, yes, we wake up with the first light, the yellow color light. If you see, the sun is yellow in color, and then it becomes white, white, white. At 12 noon, it is exactly white, and after 12 noon, it again becomes yellow in color. Yeah, so at 9 a.m. or at 10 a.m., you have got the maximum high awareness time. Yeah. So at that time is the high awareness time, and this is what we try to achieve. And as the day progresses, by 3 p.m., there is a drop in awareness, and this is the time where you need to take a coffee or an espresso. So your intelligent lighting control system takes care of all this aspect. Yeah. This study is linked to two important hormones within our body. One is called as the melatonin, and the other one is cortisol. These are the two hormones which is excreted in our body, and melatonin is the hormone which is coming from our brain, from the center of our brain, and this is also called as a sleep hormone. So the more the melatonin level, more sleepy you are. Yeah. So how we do this balance? The balance is over here. So you see this chart. So the cortisol is the hormone which keeps you active. Yeah, so the cortisol level is on its peak at 10 a.m. in the morning, between 10 or 9:30. Yeah, and if you see the melatonin level, which is over here, it's set to stop at midnight, 3 a.m. So that is at when you are at your deepest sleep. Yeah. And this is a balance which we try to do it. Previously, human-centric lighting control was used inside hospitals, people with special mental disabilities. All these projects used to have human-centric lighting control. But now more and more specifications for kindergartens, for schools, for officers, all of them, they come with human-centric lighting control. And this is where we are also very strongly working with our sensors and our controllers. Yeah. So this balance plays a very important role. Yeah. So Coca-Cola is always linked with happiness. Actually, whenever you take any sugary drinks, it tries to suppress the level of cortisol, and then you feel a little bit relaxed. Yeah. So this slide explains you that how this balance between cortisol and melatonin is important. On the other hand, you see espresso. The research in US tells you that if you take a shot of espresso, it delays the level of melatonin by 40 minutes. Yeah. So in the night time, if you take it, yes, you can take this if I'm driving between Abu Dhabi and Dubai. At that time, if I take a shot of espresso, 40 minutes my melatonin level comes down. And apart from that, also the lighting, what you see, the street lighting is also yellow in color. So it also keeps you a little bit active. Yeah, white driving. So these are the two important aspects of creating a perfect balance between the two different hormones within our body. So we tell this, we are the one who creates the perfect process. So our one room, one sensor technology not only takes care of the illumination or the brightness, presence or occupancy, but it also takes care of the human-centric lighting control aspect. It's also a temperature controller. It can also measure the CO2 level. It can also measure the humidity. Yeah, so the sensor is a full-fledged one room, one sensor, which is also a sensor and a controller. And it takes care of lighting. It takes care of occupancy. It takes care of also the temperature, humidity, and air quality. Yeah. So we create this perfect balance. Literally, if you ask me, we have fractured this balance between cortisol and melatonin. So yes, you have to go back to nature, morning walk, prayers in the morning. There was a big debate that why we should turn on the school, start the school at 6 a.m. or 7 a.m. in the morning. Let's start the school at 11. But as I explained you before, the high awareness time for the kid is between 9 a.m. to 10 a.m. So you get programmed. When you get up in the morning, you go for this morning assemblies. So it's all linked. Why? Because we're trying to come close to the nature. So technology also helps you now here to come close to the nature. How do we do this? So in the market you get bicolor LED, which you see over here. So it has got the yellow portion and it has got the white portion, and we try to play with with the color temperature. So for example, 6 a.m. in the morning, it's been kept at 2700 Kelvin. As the day progresses, yeah, so you can go at 12 noon around 7000 Kelvin or 6500 Kelvin, and then you can also come down in the same fashion back to 2700 Kelvin by 4 p.m. or by 5 p.m. Yeah. So this is what you see. Typical example of a patient room, where in the morning it's yellow in color, then it goes into the white color, and then again in the evening it goes back to yellow color. So by doing this, you are trying to come close to the nature. So there are two types of concept in the market. You can use an LED, an RGB light to do this, a bicolor LED, or it can be also strip light with yellow and white light built in it. Yeah. So that was human-centric lighting control. I'd like to end this with one slide. If your child is doing this in the night, please stop this, because this is the thing which fractures the balance between cortisol and the melatonin. So in the night time, it is completely dark. The light from your mobile phone will delay the secretion of melatonin. And I already explained what happens if there is a delay in the secretion of melatonin. Yeah. Coming back to the concept of intelligent lighting control, I would like to emphasize here on two important points. Yes, if one of the lamp fuses, changing this lamp is a cost. You agree with me or no? Yeah. And if it's a stadium, something like this, or an expo pavilion, what you see over there, if you want to change a lamp, technically you need to take a tower wagon, you go up and you change it. Yeah. But in Siemens intelligent lighting control system, or you get this information on the BMS PC or the lighting control PC. How we do this is, for example, if I buy this lamp from GE, Philips, Osram, or any of the manufacturer, the manufacturer will tell you that this lamp is designed for maybe 50,000 hours, 40,000 hours LED lights, or 20,000 hours. You have this information with you. Now in the modern controller, what you do, you take this information and feed it inside the controller. So whenever the commissioning engineer works on Siemens lighting control project, without paying anything extra, you get this feature. Yeah, you can put a threshold that if I cross 20,000 hours or if I cross 30,000 hours, please give me a notification. Imagine if there is a match going on over here, football match or an Olympic match going on. You cannot tell an athlete, oh sorry, my light went off, can you run again? You cannot tell them this. But in the intelligent lighting control system, the system will tell you, please plan your preventive maintenance because this lamp is going to fuse. And then you can check in Amazon what is the rate of the lamps. Maybe in one shot you can change all of them. Yeah. So the intelligent lighting control controllers gives you all this information on the tip of your finger. Yeah, you can actually monitor the real-time monitoring of the run hours of the lamp. You can do this. Also, whatever precaution I take, yeah, because if you got the switching module, whenever you open and close the circuit, there is always an arc. Yeah, so what you see here is an arc when you open and close the circuit. And all the circuit breakers which you know, vacuum circuit breaker, air blast circuit breakers, SF6 circuit breakers, they are all designed to quench this arc, as we all know. So what we do here is after certain switching cycles, the contact, even if I put gold, it will oxidize. Yeah. But in Siemens controller, I can tell you, for example, if you got a high pressure discharge lamp and you're controlling it with our controller, you can also feed this information. The controller will tell you that for an inductive load, something like this, the contact is designed for 1 million switching cycles, or 50,000 switching cycles, or 500,000 switching cycles. It will tell you. So whenever you are turning on and off, so in one cycle, so the controller will tell you that you have crossed X number of switching cycles. Again, there is a VIP event coming up or a match coming up. So you have already taken care of the lamp. But also from the contact point of view, you are well aware that this contact is going to work for 100,000 switching cycles or 1 million switching cycles based on the electrical load. So this information is also available on the components. Yeah. Now I'm going into the advanced features of the sensors within Siemens. Yeah. How the sensors can be used also for asset management. Yeah. If you see the sensors of Siemens also has got inside a Bluetooth technology through which you can track a person or a visitor, or for example, it's an hospital, you want to know where the doctor is. Just open up the app. The app will tell you the doctor is attending patient on in room number so and so. Or if you have got some oxygen cylinders, put a tag on it, and wherever the oxygen cylinder is moved in the project, the sensor will track this and will give the information, the location. Similarly, if you want to do space management, space optimization, sensor can even tell you, okay, this is the floor plan, okay, this part of the floor was highly occupied, yeah, a lot of people were there, and it can also create heat maps for the floor, so that if I have my building maintenance or cleaning company, they just don't do the routine work. The morning start from this end and end at this end. They will see in this map, okay, this area was densely crowded. Okay, as per the, you want to sanitize this place, you want to clean it, the sensor will guide you how to proceed, and you can do this. So this is the generation 2 sensor taking care of even the space management and asset management features. Yeah. One important point, when you are dealing with LED, you have to be careful when you are dimming it, because flickering of LED always happens. If you see LED, there is no standard for LED. If I say I have got a T5 lamp or fluorescent or a metal halide lamp, there is a standard. But for LEDs, there is no standards. Yeah, you see all those companies coming up that we sell LED lamps, but the actual challenge comes when you dim an LED. Yeah. So what we did is we came out with a controller which is designed for dimming any LED load, and we guarantee that there will be no flickering. So that means we don't need any minimum load to control the LED lamps. Yeah. So no minimum loads required, and this is how we work. We can define a smooth dimming curve for the LED lamps what you have. For example, now in my house, I have got like 6 LED lamps. When I try to, from my controller, when I try to give a command to this lamp, turn on the lamps with 53% or 50%. One is at 53%, one is at 50%, one is at 45%, one is flickering. We don't know, because you don't know the nature of the LED, yeah, how the holes and how the protons they work, yeah, you don't know the nature. So what we do here is we define a smooth dimming curve for all these 5 lamps. So if I got 5 lamps, so I start from 0 to 100%, I do a dimming, and I tell my controller that define a smooth dimming curve for these 5 lights. So when the controller will say that in order to have no flickering, you need to start with 20% of the power, and then you need to go to 100%. And when you dim down, you also have to dim and stop it at 20%. Don't go below 20%, otherwise the flickering will happen. So this is what the controller does, and we, by doing this, we guarantee that there will be no flickering of LEDs. Yep. So the sensor, what you see here, is not just for controlling the external lights. Yeah, it is a weather station. Yeah, it can also tell you what is the temperature outside, what is the humidity level outside, and it can also be used to control external blinds. Yeah. So what you see here, this part, there is the sun is over this side, so this is completely closed, and this part, if you see, the sun is not there, so it's open. Yeah. So you can also do external blinds control with the sensor. Now I'll go into the next part of the presentation, which is the demand-based HVAC controls. Yeah, the same sensor is used here for total room automation. Yeah, I will be now, both of these fields, lighting and HVAC is very correlated. They go hand in hand. Yeah, if I talk about room automation, I will be also explaining you in a conventional system, when you have a conventional controller to take care of a lighting system and a conventional controller to take care of an HVAC system, what are the drawbacks when you have such an independent system working? It has to have some intelligence where both of them they talk to each other, and that is the real concept of total room automation. Yeah. So what exactly we do in demand-based HVAC controls? I was just discussing with you on the HVAC part. So I'm here on this. So any type of your HVAC, whether it's your VRF controls, FCUs, AHUs, FAHUs, they can all be controlled using the demand-based technology. Again, with one sensor, with one room, one sensor technology as well. Yeah. So the conventional way of controlling, for example, I'll take a hotel. Previously, you used to see there is a key card where you put the key card, and there is a presence detector which used to also see the person inside the room or room. Actually, those sensors were not a real presence sensors. People, they say, I am selling a presence sensor, occupancy sensor, but they are not true presence detectors. So the sensors what we are talking here is a true presence detector. It compares your body temperature with surrounding temperature. It does not require motion. Yeah. So the sensors which comes in, presence detector can actually replace the complete key cards. It can also replace now the thermostat. So you can have one sensor where you can even define the set point. And if you want to change anything, you can do it from your mobile phone or from the bedside panel. You can do it. Yeah. So everything can be done in a modern way. Yeah. monitoring of CO2, monitoring of temperature, monitoring of brightness, opening and closing the curtains and the blinds automatically. All can be done in the total room automation. So the sensor, it's taking care of the CO2. Indoor air quality is a very important subject. Today's discussion is on the total room automation, but yes, we can also discuss on the indoor air quality, temperature control, or going into the primary controls. So the sensor takes care of all these three aspects. And then what you see is the lighting control, dimming of LEDs. The sensor can also do a constant brightness control. Yeah, and then if you tell me that, okay, no, I want to measure the CO2 level not at the ceiling level but at the wall level, then at the switch level, sorry, then even we can do this by adding a room unit to have a manual override as well as to monitor the CO2 level. So there is an indication for the CO2 level, yeah, on this. We have recently done this in a project in Sharjah where everyone wants to see exactly what is the temperature, what is the humidity, and what is the air quality within their space. Whether you've got children inside, whether you got your family member in. Okay, to be honest, I have not been to my flat in Bombay for almost now 2 years. Yeah. But the technology can tell you. Inside my flat now, we have got some nice carpets, some nice furnitures. If the humidity level goes up, the carpet may start smelling and the furniture may get spoiled. But the advantage of total room automation is the sensor will tell you that what is the humidity level, what is the temperature within your room, and from any point you can turn on the air conditioning system if it is required to maintain a threshold of maybe say 32 degrees or 28 degrees. You can maintain it instead of the temperature going to 45 degrees. And if the humidity level is very high, you can turn on your FAHUs and the fresh air you can pump inside the room. So all of these you can do it. Even the same case goes here. People have got villas here and they are staying in Europe and US, and only in Christmas time they come in. If they really want to monitor this, they can do demand-based HVAC control here by using just one sensor. Yeah. So let me explain you what exactly is total room automation. So what you see on the left-hand side is basically this free arrangement. You might have seen this in a lot of projects. A thermostat to control the air conditioning system. Yeah, for being in a split unit. On and off switch to control the light, or a conventional dimmer to dim the light. Yeah, and very famous software remote control to control the blinds up and down. Yeah. But in Siemens solution, when we talk about total room automation, they're all linked together, yeah, and they're all on BACnet IP, yeah, on the BACnet IP protocol. And you got a smart room unit, yeah, with the green leaf. Now, irrespective of how many rooms, yeah, it could be an apartment, it could be a villa, all of them gets integrated to the Siemens total room automation system, yeah. And let me give you an example. So, for example, this is an office space. There is a meeting which is going to happen and the people are sitting. It's a very sunny day and you see here the blinds are down, yeah, and the lamella is also adjusted in such a way that you don't get the heat inside the room. And one person just gets up and what he does is he opens the blinds. The moment he opens the blinds, when the sunlight comes in, the space gets heated up. When this happens, you will see an indication on the room unit. The green leaf has become red. It means I'm not feeling comfortable. I need to go and change the set point. Extra burden on the HVAC system. Yeah. But if in the Siemens total room automation, you can just come and press this, so it becomes again green. Yeah. And you see the blinds coming down, and the lamella is adjusting in such a way that you don't get the direct heat inside the room. Yeah. And it again becomes green. Yeah, but if you have a conventional system, you have to go and you have to play with the set point, or you sweat like how I'm sweating right now. So this is how the total room automation system works. Yeah. You can raise the blind. Yeah, if it's a windy day or if it is raining, the external blinds can be protected as well. Yeah, can be also protected. You can optimize your blinds controller. If the brightness is more, you can bring down your blinds and adjust your lamella. If there is an emergency, if there is a fire inside the room, now the lighting control system will guide you to the nearest emergency exit, and it will show you the way. Hello. Yeah, and it will show you the way how to take the nearest path. Yeah. Similarly, If the brightness is less, the sensor measures this and it gives you an information that the light needs to be turned on, not just on, but into percentage of constant brightness control, which I just explained. So the light which is next to the window is turned on with 25%. As you go towards the corner, the illumination increases and it tries to maintain a particular brightness threshold which you define it. Yep. Similarly, air quality plays an important role. So there is a symbol of air quality. Yes, if your air quality level is around 400 to 500 ppm, green color, 718, 700, 800, it is becoming yellow. And if it is above 1000, it can be red. So you can also monitor this. Yeah, indoor air quality. And this can be again connected to a router through which you can control it from any part of the globe. Yeah. Finally, yes, data security plays a very important role for us. And with all our routers, we ensure the maximum data security. And I think this is the last slide from my end, talking about the data security. And if you have any questions, I'm at your disposal. Yeah, please. Thank you. Any questions?
Anyone from the
Please feel free. Or you can even contact me. Yeah, you have my contact detail. You can also share my business cards with you all and be in touch. Yeah, thank you. Sure, it's no, it's not because of it. I don't.